welcome back. We are doing 2024 Level 2 Math Algebra. I know many of you found this hard. Let me solve them. I'm gonna solve them really fast. So pay attention, please. So starting with the question 1a. Write x squared plus 8x minus 5 in terms of that. So obviously this is asking you to express in terms of completing the square. So to do that, you have to go x and then plus half of 8, which is 4 squared. Let's say negative 5 is still there, right? However, when you expand this, you get x squared plus 8x plus 16, right? We just made it up, so you have to take it away. So you go x plus 4 squared minus 21 should be the answer, right? Now, question B. Find the discriminant of the quadratic equation that. So, discriminant is b squared minus 4ac. So, you have to rearrange it in the form of ax squared plus bx plus c equals 0. And then you spot a, b, and c. That's the question. So, you go 3x squared minus 5x plus 2 equals 0, right? So, b squared means 25 minus 4 times 3 times 2, right? So 25 take away 24, which is 1. Perfect. Good. Next question, I already solved it, so I'm going to explain with a different colored pen. Oops. Can I? Well, I'm going to use blue. Now, I will try. Hold on. Can I? No, never mind. So single fraction. So what I did here, I found lowest common multiple among t squared and 3t, which is a 3t squared, isn't it? To match with that, with the first fraction, you have to times by 3t, and second fraction times by 3, right? Because it's t squared. So I'm saying here you times by 3t. Times by 3t, and here times by 3 times by 3, okay? And here times by t times by t, and you get that, and then you have to expand, so you get 3t plus 3t minus 15 minus t. So you simplify. Hold on. 6t take away t is 5t, isn't it? Take away 15 over 3t squared should be the answer. All right. Now, a cubic polynomial is given by that, and ABC are constants. The graph of the polynomial has 3 roots, and cuts the x-axis at this. So that means -2, 1/3, and 4, they are roots, isn't it? Using your knowledge of roots, find the value of the constant. So as you see 3, it's on purpose, isn't it? Because one of the roots is 1/3. So you go 3 times x plus 2, yeah, and then what? Because it's minus 2, so that's why plus 2. And because it's 1/3, so it's x minus 1/3, right? And then 4, so that's x minus 4. And then what I did is I times multiply 3 by x minus 1/3. I get 3x minus 1, right? And then what I did is I multiply x plus 2 times x minus 4. I got x squared minus 2x minus 8, right? And then times by 3x minus 1. And then I get 3x cubed minus 6x squared minus 24x minus x squared plus 2x plus 8. I go 3x times everything inside, and then minus 1 times everything in that bracket, and then simplify like terms, right? So 3x cubed and minus 6x squared minus x squared add up to minus 7x squared minus 24 4x plus 2x is minus 22x, and then plus 8, right? And then be careful because it says find the value of the constant. So you have to say A, B, and C, right? So A is negative 7, B is negative 22, C is 8. Okay. Next question. This question I found it's not that hard if you understand index rules. So what I did is just like a for method, you multiply, right? So x to the power of 3 over 2 times x to the power of half becomes 2, isn't it? Because I'll show you one example. So x to the power of 3 over 2 times x to the power of half. So when you multiply, you have to add indices, right? 3 over 2 plus a half is 4 over 2, which is 2. That's how you get x squared, right? And then between these two, well, that's negative. Hold on. So 3 over 2 minus half is 2 over 2. It's 1. So x. And then x to the power half times x to the power half is 1. And then you cancel out. Then minus x plus x is 0. And then x to the power half times minus x to the power negative half becomes x to the power 0, isn't it? Which is 1. And the bottom one, you know, a minus b squared is a squared minus 2ab plus b squared. So that's how you get this. So the numerator is x squared minus 1, and denominator is that. And you see x squared minus 1 is actually x plus 1, x minus 1, right? And the bottom one is a cubic expression. And you factorize by x, you get that. And you see x squared minus 2x plus 1 is x minus 1 squared. So you cancel x minus 1, x minus 1. So that's how you get x plus 1 times over x times x minus 1. Okay. Question 2. Solve this. So obviously you times by x on both sides, leaves 3x squared minus 14x equals 5, and shift 5 the other side and factorize it, and x is 5 or negative 1 over 3 each question. Just like you want to double check, x can't be 0. It's not 0, so it should be fine. So they are the answers. I check them. I just plug them and see it works. Now simplify this. So I expect inside this square root must be something squared. So obviously 9x squared plus 30x plus 25 is a 3x plus 5 squared. So square root and square you cancel out, and the 5x plus 3x squared becomes x, 3x plus 5, and 3x plus 5 you cancel each other. Well, left is 1 over x. This question C has numerically equal but opposite signs. To be honest, this question, took me a while. But it's a good question. I liked it. But what I did is, k minus 1 over k plus 1. I let a equal to k minus 1 over k plus 1. That way it's easier, all right? And well, the wording, what does that mean? That means like x squared equals c, right? Constant. Then x must be plus minus square root of c, That's what it means. That's the case. So when you have x squared minus 2x over 4x minus 1 equals a, and you times by 4x minus 1 on both sides, and you rearrange it. So that means that part, the terms of x should be 0, isn't it? Then x squared equals plus a equals 0. Hence, x can be plus minus square root of a. Well, in this, So we have to say 2 plus 4a equals 0. So 4a is negative 2. A must be negative half. However, we are not finding a, but finding k. So I substitute a to k minus 1 over k plus 1. So you have to substitute back. So k minus 1 over k plus 1 is negative half. And times by k plus 1 on both sides leaves k is 1/3. So, It is a challenging question, but it's a good question. This one as well. The logo for an IT company, Doctor of Data, is shown in the diagram to the right. So find the expression in terms of x for the area of the circle in the middle of the logo. So find the circle. Okay. So you will see this question 1 is kind of scaffolding for question 2. So you see because this is x and you see it is altogether 2 circles, right? So it means to find the radius r, that is r must be what? X over 4, right? So you just plug that into r. So a equals pi x over 4 squared. So which is what? X squared over 16 pi is the area of circle. Right. And now question 2. If the green background has an area of 10, find the length of a rectangle. So the length of length means the longer side, right? So shorter side is width is x over 2. So find the x is the question. So the shaded area is the total area, which is x times x over 2, minus 2 times the circle, is 2 times circle, we got there, and x squared over 2 minus that gives me that equals 10. So x squared equals x squared times 1 minus pi over 4 must be 20, right? I'm solving this equation, right? So therefore x squared is 20 over 1 minus pi over 4, which is a 3 pi over 4, and 80 over 3 pi. So x must be plus minus square root of that, but x can't be negative, so square root of 80 over 3 pi. You can just leave it quick answer like this, or convert to 2.9 centimeters 1 dp. Should work. Okay, solve x, easy question. So according to the log property, this is log 625 over log 5. So x is how much? Well, 625 is 5 to the power of 4, right? So 4 comes front, log 5 over log 5 is 1, so the answer must be 1. All right, solve this. First of all, left-hand side is 3 squared bracket 2x plus 3, right? And the right hand side is 3 to the power of negative 3 to the power of x. So that means 3 to the power of negative 3x. That means 4x plus 6, right? So expanded equals negative 3x. Hence x must be negative 6 over 7. So log x to the base of b is 2, log y to the base of 3b equals to, write the y in terms of x, each question. So from this, x must be b squared, right? From that, y equals 3b bracket squared. I bet many of you forgot that bracket. So that is 9b squared, right? So as you know, b squared is x, so you plug x into that, and y must be 9x. Consider that where k is constant, using the quadratic formula, find the fully simplified solutions. Each question is a, b, c, right? B squared x equals 1 minus b plus minus square root of b squared minus 4ac over 2a. Actually, because this is even number, you could use shortcut, but I don't want to confuse you, so I'll just follow normal the quadratic formula. So minus b, which is 4k, plus minus square root of b squared, 16k squared minus 4ac. And then that's 12k squared. So 16 take away 12 is 4k squared inside the square root. So that becomes 2k. When it is plus 6k over k, hence that should be k. And the other one is 4k minus 2k over, so 2k over 6, so k over 3. So I'm going to write the answer again. K or k over 3 should be the answer. Okay. That was quick. So last question already. The level of sound is measured on a log scale using a unit called a decibel. The formula for the decibel level D is given by that, where P is intensity. You can read that. What I did here is that, I just labeled the DC, so decibel over C, which is which indicates a cooling fan. So that is a 10 log P. Actually, I should have said PC, isn't it? Intensity of a fan, the cooling fan, over P naught equals 38. And therefore log PC over P naught is 3.8, right? Divided by 10. And same way, D over H is 10 that. So I can say P log PH minus log, so this is my log, sorry, P naught equals 3, right? By the way, did you know that is actually log PH minus log P naught, right? So that's one of the log properties. So this is like a solving simultaneous equations, isn't it? When you take away, you get log PC, take away log PH. Log P naught is eliminated. So 3.8 divided by 3 is 0.8. So again, because it's minus, that means you can express as a fraction. So log PC over log log PC over PH is 0.8. That means PC over PH is 10 to the power of 0.8, which is 6.3. That's how you prove it, right? Okay. I hope that helped. Okay, I will see you next time with the characters. All right, bye.